This is Math 2 5.4 notes. That's Unit 5, Lesson 4. And the title for today is Trapezoids. Alright, this is the last type of quadrilateral we'll be talking about for this test. And a trapezoid is a quadrilateral four-sided polygon with exactly one of opposite parallel sides. Okay, so we're going to draw one. Draw that base again. Okay, so there is our trapezoid with exactly one pair of opposite sides that are parallel. So we're going to say that side is parallel to that side, and you can tell that these two sides are not parallel. Now, depending on who you ask and what website you look up, some may say a trapezoid has at least one pair of opposite parallel sides. Some say exactly one. The one we use in this class is exactly one pair of opposite parallel sides. All right, so this is what our images will look like for our trapezoid. Okay, so we're going to call this angle A, angle B, angle C, and angle D. And pieces, what are they called? This is called base 1, base 2. Doesn't matter which one's base 1, base 2. And these two are our legs. Leg, base 1, base 2. All right, what you should know about a standard trapezoid is that the measure of angle A plus the measure of angle D will always add up to 180. And the reason is, if you can see the C shape here, the arms of my C are parallel, which means that these two are same side interior angles and they are supplementary. The same is true on this side. I have a backward C here, if you can see it, and the arms of my C are parallel, same side interior angles, which means they are supplementary. So the measure of angle B plus the measure of angle C equals 180. All right. We are going to talk about a different type of trapezoid, a special type. It is called an isosceles trapezoid. All right, and this is a trapezoid, which is a quadrilateral with exactly one pair of opposite sides. But just like a isosceles triangle, it has congruent sides as well. Okay, so I'm going to call this again A, B, C, D. This is still base 1, and this is still base 2. And the added piece is that these two are congruent. The legs, leg, the legs are congruent. Up here they were not. This is just a regular old trapezoid. If it's a special isosceles trapezoid, the legs are congruent. Okay, so remember, this is our isosceles triangle from a previous unit. Those were the congruent angles, and this side right here was called the base side. Okay, we're going to talk about that in a little bit. First off, we should know the legs are congruent, so let's go ahead and write that down. There's a lot of pieces we're going to write down. Legs are congruent. That's one piece of information you will need to know. Legs are congruent. Those are the two legs. That's what makes it an isosceles triangle. The next piece is same as before. A plus D is 180, B plus C is 180, and that's because I still have the C shape because these two are still parallel. The C with the parallel arms A backward C with the parallel arms means the measure of angle A plus the measure of angle D equals 180. The measure of angle B plus the measure of angle C also equals 180. All right, there's a few more pieces we're going to add. There's quite a bit for an isosceles trapezoid. Just like here in an isosceles trapezoid, the base angles were congruent. Same thing. If this is my base side, these are my base angles. So angle D is congruent to angle C. Now I have two bases. This is also a base, which means those are also base angles, and angle A is congruent to angle B. Now these are bases up here as well, but those base angles are not congruent because the legs are not congruent. Because this is not an isosceles trapezoid, those angles are not congruent. It only happens when it's an isosceles trapezoid that base angles are congruent. All right, and the last piece is diagonals. Diagonals are also congruent when you're dealing with an isosceles trapezoid. So AC is congruent to BD. All right, so we have a lot of bits and pieces here for an isosceles trapezoid. This one here is the same as a regular trapezoid. Everything else is added stuff, new stuff, because it's isosceles. All right, let's try an example. I want you to, we're going to call this number 1, find the missing angles. Find the missing angles. All right, well, let's go ahead and draw our trapezoid. I'm going to draw it like this. Okay. I'm going to mark this A, B, C, D. I'm going to mark that those two sides are congruent and that this is 60 degrees. And that's all I'm going to give you. Those two, oh, and parallel, of course, because it is a trapezoid. Those two are the parallel sides. Those two are the congruent legs. Now, I didn't tell you it was an isosceles trapezoid, but according to the markings, it is a isosceles trapezoid. And angle D is the only angle I gave you. I want you to find the measure for angle A, the measure for angle B, and the measure for angle C. Now, what do we know about A? A and D. Are those two angles base angles, or are they the angles that add up to 180? So if you were to flip it like this, if those two are my congruent legs, this is a base side, which means those are my congruent angles. So angle A must be the same as angle D, which is 60 degrees. All right, angle B, if you put it again on its side, you can see the C shape. There's my C, and the arms of my C are parallel, which means these two are not congruent, but they are supplementary. They add up to 180. So if this is 60 degrees, then I'm just going to put an X here. 60 plus X equals 180. 60 plus X equals 180. Subtract the 60. X equals 120. So angle B is 120 degrees. All right, so I'm going to flip it back on its side. What do we know about those two angles? This is also a base side. There's base 1, there's base 2. And remember, when it's an isosceles, base angles are congruent. So that's set. They're not all congruent to each other, but those two are congruent to each other, and these two are congruent to each other. So if we just found B to be 120, C must also be 120, which makes sense because if this is 120, these two should add up to 180, and 120 plus 60 is indeed 180. All right, so you'll have problems like this on your assignment as well as quizzes and tests. All right, back side. we are going to go over mid-segment formula for a trapezoid. Now this trapezoid formula, mid-segment, does not need to be isosceles. So I'm going to go out of my way to make it look non-isosceles, because it does not have to be isosceles to use this formula. And mid-segment works just like it did for the triangles. It cuts your sides in half. Now, they're not congruent across, just on the same side. Those two are congruent, those two are congruent. We call this the mid-segment. We call this still base 1, and this base 2, and there is a formula. So, if I gave you something like this, this is us thinking from last unit, and I cut that in half, and that in half. The formula for this was, if you remember, double the mid-segment equaled the base. Double the mid-segment equaled the base. You did this one times 2 to equal the base. Same thing, we're going to double the mid-segment to equal the base. Only thing is, there's two bases. There's a base 1 and base 2, so we add them together. Base 1 plus base 2. We didn't have to worry about it on triangles because there was only one base in reference to that mid-segment. But here, we're going to double. And again, just like before, those two will be parallel, as well as those two. Okay, so I'm going to call this number 2. Example, solve for x. Okay, let's draw our trapezoid. Oh. Okay, parallel, parallel. One set of opposite parallel sides means it is a trapezoid. I'm going to go across, put markings there, there, as well as on the other side, which means that middle is the mid-segment. And I'm going to label that 2x plus 4 for the mid-segment. The top base is 2x plus 1, and the bottom one is 3x plus 2. Okay, you're going to have something very much like this on a quiz, on a test, even on the worksheet we're going to do in class. So, solve for x. Because of those markings, we know that 2x plus 4 is the mid-segment, and according to this formula, we double the mid-segment. And some of you forgot to double on the last test, on the one like this, on this type, so please don't forget to double. Equals not just base 1, but there's two bases, so we add them together. 2x plus 1 for base 1 plus 3x plus 2. It doesn't matter which one's base 1, base 2, you're adding them together. 2x plus, don't forget you do have to multiply both of them, and that is not a 2x, that is a 4x. 4x plus 8 equals 5x plus 3. And I'm going to go ahead and let you finish solving for x, and we'll check it in class. That is it for this lesson.